Hi, and welcome to this session with Illumio. My name is Trevor Deering, and I'm the EMEA Director of Technology. I want to talk to you about breaches and fundamentally how we can stop breaches, and also how, if they happen, how we can reduce the impact and the cost of those breaches occurring. But first, a couple of bits of housekeeping. So if you have any questions as we go along, please enter them into the Q&A window. We will either then answer them as we go along with the window, or we'll save them up for the Q&A session at the end. So I just wanted to really start. I mean, some of you may know Illumio, some of you may not. And fundamentally, what we do is that we protect organizations. So we're protecting 9 of the 15 largest banks, 4 of the largest SaaS companies, and we've deployed over 1 million workloads of protection so far. And these, companies are not small organizations. So it's people like Salesforce, BNP Paribas, Oracle, Yamaha, organizations like this that have a lot of either intellectual property or a lot of customer records that they need to protect. And we get, obviously very good reviews, Gartner Peer Insights, customers who review our technology. And also we are the leader on the Forrester Wave for Zero Trust. And I just wanted to sort of talk about that for a second, because this is actually one of the reasons that I joined Illumio. Is in 2019, Illumio were in the leadership sector for Zero Trust, along with a number of other companies. But now in the most recent 2020 version, Illumio is now the undisputed leader in Zero Trust. Now, that doesn't mean that you only buy Illumio and you are suddenly Zero Trust compliant, but it does mean that Illumio, along with some of the other technologies here, like Palo Alto Networks and Cisco, Microsoft, Google, allows you to make that move towards implementing Zero Trust. And Zero Trust is one of the fundamental things that help you to stop and also to control breaches. Because if you think about it, a breach is generally a bad thing. If you play those games where they say, take a word and put it into a meaningful sentence. If you use the word breach, it's difficult to come up with a positive sentence that includes that word. And please, if you can come up with one, put it in the Q&A window and we'll read it out at the end. But the things that we're interested in are really data breaches and cyber attacks. We read every day about another breach, another major breach, about millions of records lost, about, state actors, about all these sort of things. And so what we want to be able to do is to be able to mitigate that and control it. Because if not everything is a breach. So, what is a breach? Let's standardize that. There is a definition. And it fundamentally is that it's an incident resulting in the loss of personal data, fiscal or intellectual property. So it doesn't mean that every attack is a breach. It's only a breach if you actually lose something. And, to quantify this, there's an organization that some of you may have come across called Ponemon. And every year they release a report into the cost of a breach, called the Cost of a Breach Report, and you can access this in many ways from many places. And they say that the average cost of a breach is $5.86 million. And this is obviously a global average across all sorts of companies. It doesn't include the mega breaches, but it does look at how they are split by industry, by country. So if you're a healthcare organization and you're in the United States, then the cost is going to be much higher. It's going to be 10 million or something like this. But if you're a public sector organization in Asia, then that actually could be much lower. It could be as low as $1 or $2 million. And so everyone is at some point in between. And they look at it as about the average cost works out about $500 per record lost. So, if you're an organization with a lot of PII and you lose a lot of that, it's going to have a big cost. And that cost doesn't include the fine. So it's It's really looking at remediation costs. It's the, the impact, the loss of business and all those sorts of things. And one of the reasons this becomes important to us was obviously the launch of GDPR a few years ago. And everyone knows and curses GDPR because of privacy, and you have to sign lots of documents to allow people to share things, and people share things they don't, etc., etc. But part of this whole GDPR thing was also the fact that an organization, if it had a breach, needs to then notify the local authority or their local regulator. And so this throws up a lot of information and a lot of knowledge, and potentially a lot of reputational damage, because all of this is public record and you can go online and you can look all this up. So there's some good news and there's some bad news. So since GDPR was launched, the fines for breaches so far are only 140 million euros. But the UK regulator has recently announced fines of 282 million euros, mostly for, I think they're British Airways and Marriott. But recently that's been sort of downgraded because of mitigating circumstances, and I think it's down to about $20 million euros, sorry. But most of the regulators throughout Europe are now hiring more enforcement teams. So we will only see these volumes going up. So it is key that we understand, the fact that these fines will go up and up and up as time goes on. And that's going to have an impact not only on, reputation, but on the business itself. Some of the other things, or one of the other things that is affecting things is the NIS directive. And this was really created by the European Union to apply some standards to critical infrastructure. So things like utilities, power, shops, food, transport, all of those sorts of things. And the NIS directive directs the nations to be able to define a cybersecurity strategy, and also a single point of contact. So for the UK, it is the National Cybercrime Security Centre, and they have defined something called the cyber attack or cyber assessment framework, which organisations who are part of critical infrastructure need to comply with. And so that talks about several things like passwords, it talks about identity management, it talks about dual factor authentication, but it also talks about microsegmentation as being one of the things that's required. And so the idea being that if you follow the NIS directive and also this framework, then it actually helps you to prevent breaches and control things that happen. So one of the key things is really working out how we stop breaches. So if you think about, the old days, we would build our cybersecurity like a castle. So we'd have firewalls at the edge, and we try and sort of prevent brute force attacks, which were generally the thing at the time. But the thing is that if you look at a data center or a hybrid data center, I guess it's a bit like a coconut. It's really tough on the outside, but sort of soft and gooey in the middle because of the way that we need to operate. And so what we need to be able to do is while we are, we've sort of to a certain extent solved the brute force attacks, we need to be aware of the more sneaky attacks, which are the way that people do things now. So not only through people using people, through phishing and things like this, and dodgy websites, but also looking out for things like unpatched web servers or licenses for detection equipment that's gone out of date, or being able to monitor encryption and things like this. So we have to look at this whole thing in a slightly different way. And really the way to stop a breach is sort of understand how they occur. So a lot of organizations now are using the MITRE ATT&CK framework for how to deal with a breach or with an attack after it's happened. But I think the thing we need to do here is look at the whole attack. So let's look at the traditional kill chain, not only because it gives us that detail of what happens ahead of the attack, but it also looks better on a PowerPoint slide. And the bits that I'm interested really is the reconnaissance phase and the delivery phase. Because these are not only, critical in the way we do things, but probably the easiest things to protect against. Because what we have to do is work out how we break the chain. So let's think about those pieces in a bit more depth, and let's look at what's going on inside a data center. Because if you think about it from now that we've moved from monolithic applications to microservices, which we did sort of 20 years ago, ideally we want our data center to be as flat as possible. So a lot of the customers we talk to, they say, one of the key things is keeping this flat network architecture, because with all the microservices, you need reachability from pretty much anywhere to anywhere, because you don't necessarily know, if you're moving things around, what the next connection you need is going to be. So from a networking perspective, we ideally want this as flat as possible. And the good news is, because of the developments in non-blocking switches and the use of the CLOS architecture in data centers now, we can sort of achieve that. So there will be some restrictions, some VLANs and things like this. But what we can do is we can build this to be as flat as possible, to make it as easy for the application to work and make it, as high performing as possible. But there's a challenge with this. And that's when, a piece of malware or something turns up in the data center, it has free reign. So, if you can imagine that, if something is like a big hall, and things can move around very, very simply, very, very easily. And it's looking for all of the unpatched servers. It's looking for all the vulnerabilities. It's looking for all the things and the places where it can reside, so that it can take over, either then build a botnet, or it can do, whatever it wants to do, exfiltrate data, et cetera, et cetera. So for this reason, actually having a flat network isn't such a good idea. But what we really want to be able to do is to be able to segment this data center in the most simple way. Now, that's not necessarily to segment the network traffic, but to segment the traffic at a higher level. Because if you think about it, what we're doing is that segmentation reduces the attack surface. If we can break up and control where the traffic is going, then what happens is that the malware is restricted to a certain area. And that means that it can't infect other systems, other applications, other processes, whatever it happens to be. And the good thing with doing this is that it can make it easier then to detect and remediate. So we were talking about the fact that, it's not only a case of being able to stop a breach or stop an attack, but it's actually the faster we can identify and remediate it, the better. So if you think about a virus or a piece of malware, if it's restricted and can't go anywhere, it's going to act a bit like a fly in a jar. It's going to sort of bounce all over the place, trying to make connections, trying to escape, trying to do all these sorts of things. And that makes it easier, because it's in a smaller area, to be detected by things like behavior analytics, SIM systems. It's easier then to kick off a process with EDR or workload protection platforms or things like this, to be able to identify that thing. So it's going to do things that it wasn't doing before. So behavior analytics should pick up. It's going to trigger alerts in the segmentation system that will come up, that will flash up on the SIM. So by doing that, we can actually not only control where the attack is and where it goes, but we can reduce the time, because one of the key things is that reducing the time to resolution for a breach substantially reduces the cost. As if you read the Poneron report, it will show. So we're not only stopping the attack and stopping the breach, but if bad things happen, we're reducing the time to identify it, which is reducing the cost of a breach. So there are three options for microsegmentation. The first one we sort of spoke about a bit was to do this with the network. and to use SDN. So what you basically are doing there is you're creating a series of groups. So you're allocating workloads into groups and using the network to keep them separated. And this network could be a physical network with switches, or it could be a virtual network in hypervisors. But generally, this isn't recommended for microsegmentation because it's quite a blunt instrument. And so the next way you can do this is using firewalls. You could do this on physical firewalls, virtual firewalls, or firewalls that are distributed within the hypervisor. And so what you're doing is potentially creating allow lists or even deny lists to allow or deny communication between groups of devices, or between, to create those groups of devices. The challenge with this is it's a firewall, and as you scale, it becomes more and more difficult to track all the rules and all those sort of things. And also the enforcement is happening potentially too far away from the workload. So, so things are bouncing all around the network, and you're having to worry about asynchronous communications and asynchronous traffic and being able to enforce in all of those places. So the third option, which is becoming more and more popular, is to actually enforce on the workload. So again, you can create simple labels for each workload and generate rules between those workloads for the communication. And you can either put an agent onto the workload and enforce with that, or else you can enforce using the forwarding tables and the firewall that is built into that system. Because if you think about it, what you don't necessarily want to do is add more and more enforcement points, more and more agents, more and more things onto the network, because you already own lots and lots of enforcement points. Because within Windows and Linux, there are firewalls, there are forwarding tables that control the destination of traffic. They control which TCP ports to use, they control which services, etc., or you can enforce using load balancers or switches or firewalls or any of these things that you potentially already have. Because if you think about how traffic gets forwarded within a system, so everything, whether it's a switch, whether it's a router, whether it's a firewall, whether it's a server, an endpoint has a forwarding table, and that dictates where and traffic gets sent. And that forwarding table is controlled by a few things. It's controlled by a routing table. It's potentially controlled by the firewall or some other security functions. And the thing is, when you're doing and building those forwarding rules within a firewall, you're doing a couple of things. You're building allow rules, which are basically mean that you define what gets forwarded to where, or you create deny rules, which is basically said, okay, that system is not allowed to communicate with that, or that application is not allowed to communicate with that user or that application. And they're your choices. And these are the key things that allow you to build segmentation within your system. Because if you think about it, allow rules, for instance, are great because they can be used in any order. They are fundamental to zero trust, because what you're fundamentally doing in zero trust is verifying or denying. So by allowing communication between two different points, you are opening up and creating a portal for those things to communicate and blocking everything else. So it really is the key for microsegmentation. Whereas if you think about deny rules are very simple to implement. You can say, right, do not allow any communication between production and development systems. But they do need to be in a strict order, because if you get the order wrong, you can prevent things happening that you want to happen. It's a fairly blunt instrument, and over a period of time, it creates complexity, because if you've got a list of 1,000 rules and you're adding a deny rule at the top that says, stop production talking to development, What if you've got then exceptions further down, you're stopping those altogether. So you then have to make sure they're in the right order and move the exceptions above that, or, it gets very complex. But even allow rules to do that in a big system can take some effort, because for anyone who's configured firewalls and you've sat and created all these allow rules, it can take a long time. So what we need to be able to do is to simplify that process, automate that process, and to do things in a much simpler way. So this is where Illumio comes in, because what we fundamentally do is, if we take the forwarding table in a workload, so Linux, AIX, Solaris, cloud, container, whatever it happens to be, and we install a piece of software called a Venn. And what that really is like a virtual transceiver. So it activates the native capability within the forwarding table. So being a transceiver, it transmits information and knowledge and reports back, but also then pushes information down to the forwarding table to enable it to do and comply with the rules. And the Venn is controlled by what is the brain, which is a centralized policy compute engine. So what it fundamentally is doing is, with the Venn on the workloads, we're collecting context telemetry information from whatever it happens to be, the public cloud, data centers, containers, bare metal servers. It actually doesn't matter. And we use that information to build an application dependency map. So this is a map that shows how every workload is communicating with every other workload. But it's not just that information we use. We can also import flow information, so IPFix, NetFlow, logs from the cloud. So it means that if you have unmanaged devices like IoT or legacy systems or anything like that, they can be included in the map as well. And also we import then some vulnerability data from people like Qualys or Tenable or Rapid7. And what that does is that we then map that information on top. So it shows us within that map which servers are most vulnerable, where we need to maybe apply some rules to mitigate that. So we've gathered all this information, and it allows us, as we said, to track the communication between every workload. And what it actually gives us is something like this, which is like a bowl of spaghetti. Difficult to make any sense out of. It shows us all the communications between all of the workloads. Now, this is where some planning comes in, because what we need to be able to do is to sort of see that in a much more meaningful way. So a lot of the challenge is that a lot of the time, if you look at workloads and create workloads, they have a number of tags applied to them. And these tags can be fairly indiscriminate, and they can be based on several things. So a workload could have 7 or 8 tags based on a whole series of things. And the way that those tags are applied in the data center in one system could be different to how they're applied in the cloud by a different set of people. So you can get a lot of confusion at this point. So what we do is we have a very simple 4-dimensional labeling process, which is that we define the role of the workload, client, database, web, etc., what the application is, what the environment is, whether it's production or test or development, and then the location, which could be either a physical location or where it sits in a particular cloud. And we take information from a CMDB, and we apply these labels to those workloads, and it gives us something like this. So we can now start to visualize where the applications are physically, or we can look at them by application, or we can look at them by a number of different angles when we look at them within the map. And we can zoom in and out, so we can click on a location and we can see the workloads within those locations. Or we can click on the application and see the workloads within those applications. And so having this allows us to get a huge amount of information. And we're looking here at, the red lines are basically where there's no rules applied for communication. The green lines are where rules have been applied, allowing the communication between those workloads. And so, fundamentally what we do with that information is to then push policy or rules down to the workloads that are then executed within the forwarding tables of those workloads, and allow us to then apply policy. But as I said, one of the challenges, what you don't want to be able to be doing is sitting there and writing lots of allow rules, which, a lot of the time, whether it's firewalls or distributed firewalls or anything like this, you end up having to manage all those rules. So what you want to be able to do is to do this as simply as possible. So what we've done is created something called Policy Generator. So, for instance, if we wanted to do circle an application, if we wanted to, control that, just keep that application separate from everything else, we literally could push a radio button, and it then generates the rules, and we see the rules below all the connections there that exist between connecting all the workloads to each other within that application. Then, if we want to go to a different level, say we want to do it by tiers, we click the role level services button, and it creates the rules that apply there between all of the various bits and pieces. And so it's very, very simple to apply those rules. It can be, rather than taking hours to write a load of allow rules for a firewall, what we're doing is hitting the click of a button, and within seconds we can apply those rules. Now, if you look down the side, what we'll see here is also where it talks about exposed vulnerabilities. And this is the information that we're getting from the vulnerability scanners that allow us then to apply rules based on how vulnerable certain workloads are. Now, it could be that we actually, we create those rules, but we want to apply some more. So if we go back to our map and we see that we have some links here between two production networks in the New York data center that don't have rules applied, what we can do here is literally just click on the link, and it brings up the option to add a rule. And it shows us what the rule is, and we can click save, and it will then apply that rule. And what we can do is actually go into 3 stages of deployment. So that could be purely a build or visibility phase, where we're literally just collecting and seeing, like a what would the connection look like if we applied that rule. We can put it into a test mode, where we actually are then seeing the effect that those rules would have on live traffic. So we can still generate alerts to a SIM system, so that we can, we can see what happens, or if there's any potential attacks or anything like that going on, before we then hit the final button, which is build, or enforce, which then actually turns the enforcement on that system. So you can actually test the rules on live traffic without actually affecting that live traffic, to check that those rules won't actually break anything. And then the other thing that we can do here is, if you look here, there is a button here called Secure Connect. And what that does is fundamentally it turns on encryption between those workloads. So the challenge is, if you're, in certain circumstances, there is a requirement to encrypt data between systems. So if you have maybe a Linux workload on AWS, and you have a Windows workload in your data center, and you want to encrypt between the two, if you're using distributed firewalls or anything like that, it gets very complex in doing that. Well, by a simple click, we can actually turn on the encryption between those two systems. So what we see here is a very, very simple, efficient way to apply policy and rules. And one of the key things is just the time it takes to do that. And it, by taking this approach as opposed to maybe writing lots of firewall rules or trying to do it in the network or anything like that, just simplifies and speeds up that deployment and that approach, and it makes it far, far easier to actually do this. But as I said at the start, it's, and when we spoke about zero trust, you can't just go, hey, we're going to buy Illumio and we're now zero trust compliant. What it becomes about is how it then interacts with other things. So for instance, the fact that we can generate a lot of alerts and information about policy changes, events, activity, etc., that we can pass up to a SIM system. The fact that we can import vulnerability information from a number of vulnerability scanning products that then allows us to adjust the rules to I guess counter and to deal with the fact that certain servers may be patched and others maybe not. The fact that we can import metadata and information and tags from organizations like ServiceNow and VMware. And in fact, we can then, as we observe things, we can actually use that information to update the CMDB because, you know, it becomes the real life point of truth. And then by being able to import net or flow records in general from a whole series of different sources allows us to build a network map that includes everything and not just the workloads. So as I said, IoT devices or legacy devices or whatever it happens to be. And we can push ACLs and rules down to switches or virtual networks or load balancers or things like this. And then finally, obviously, you know, there will be, and you need to have firewalls within your system to put at the perimeter to control communication between sites and geographic sites and various things like this. And so what we can do is that we can map our labeling to dynamic address groups within Palo Alto Networks firewalls to make the management and control of the firewall much, much easier to deploy. So we got to the point now where, you know, policy is really tied to the workload and is not tied to the network because, you know, ideally what we need to be able to do is to decouple the segmentation and security from the network, because the network could be anything. The network could be a cloud, it could be on containers, it could be in a data center, and it can move. So what we don't want to have to be able to do is to think, okay, this is now moving from AWS to NSX, and so we have to change the rules and the way we work and the way we deploy things. By abstracting that and doing things on a workload to workload basis, it actually doesn't matter where that workload exists. And we can imply, as I said, segmentation in multiple ways. So either environmental, which is fairly coarse-grained, we can do application ring fencing, tier segmentation, which is, you know, most common, or we can actually get down and segment individual processes on individual workloads if we want, in a very, very simple, graphically controlled way. So by doing this, it simplifies the deployment of microsegmentation. It allows us to control where we put the breakpoints. It allows us to contain any potential breaches. And if there is a breach, it allows us to work with other tools to be able to speed up the remediation and control of that breach, which not only can stop the breach, but also if the breach occurs, can then reduce that cost of the breach. So hopefully that has given you some insight into what we do, given you some insight into how to control and manage some breaches. So what we'll do now is we'll go through and highlight and look for any of the questions that have been posed during the during the session, and be able to obviously deal with any follow-up. So thank you for that, and let's get to the questions.